So now we are going to see the application which I have chosen to call condensing boiler. What is important when we have a natural gas fired boiler, as what I've tried to illustrate here, is that the overall HVAC system should allow the boiler to condensate. And what that means is that the moisture in the flue gas will have a temperature which is so low that the water or the moisture in the natural gas, the flue gas which is leaving the boiler, is able to condensate on the different surfaces in the exhaust system. In that way, we kind of harvest the last part of energy which is captured in the flue gas. But there's one important element which needs to be in place for that to happen, and that is the return temperature of the water going back to the boiler, because it's actually this return water which should give the cold surfaces on parts of the boiler where the flue gas needs to condensate. Typically we say that the return water should be either on or below 57 degrees Celsius, which is equivalent to 135 Fahrenheit. But it can be quite difficult to really establish the conditions where there is condensing mode at all times. For that reason, a number of different solutions can be found. We could equip the system with a three-way valve, which is at all times is securing that the return temperature which the boiler will receive is below these mentioned temperature levels. So if the water is too hot, it will simply be recirculated out to the flow pipe again before it's let into the boiler. A quite complicated and expensive way to do this, by the way. Another way of doing this is to simply adjust the overall flow in the HVAC system to a level where it is not exceeding the design criteria which is set. And by doing so, we can adjust this pump throttling valve and then secure that the overall flow in the system is not exceeded. Also a little bit of a complicated way of doing it, but I would guess though not so expensive as the first solution shown over here. One alternative to doing it in this way is to utilize the functions or the features in the magnet-free pump and then simply eliminate this valve here, and then instead choose the features. Maybe we have set the pump to operate on a certain level of proportional pressure, and then what we can do is that we can allow the flow limit function to work, and then secure that we will not exceed the specific design data for the system, which is illustrated by this vertical line here. So in that way, we secure that the water flow in the system here is not exceeded at all times, because if it was exceeded, we would risk that we would have too high temperature back to the boiler here. But that we can control by the features in the magnet-free pump. In this case, the flow limit function. I hope you will enjoy using that feature. Thank you.